Hello, everybody. In today's video, we're gonna be creating a deep learning model using TensorFlow and Keras, of course, that actually looks at a hot X-ray and gives us the result. Basically, the sum up of this is just I would say, have you ever been to to the hospital and it just kind of like went in for an X-ray and in the next 5 minutes your result is out? Boom, right there. So what we do basically, as we all know, the technological space is evolving, and um, we can use machine learning models these days to determine if the person have malaria or have heart disease, or just go ahead and mention different type of illness. But today we're gonna be focusing on COVID-19. Basically, it's just a sample. The data is gotten from Kigo actually. So we're gonna be actually creating a deep model using TensorFlow and Keras to predict if a patient have if a patient have COVID or not. So in order to do that, we need to train the model with three different types of images, actually. Number one category will be a person will have a viral pneumonia, because we probably know that, most of the people who died from COVID are people who already have some type of illness, right? And then, secondly, we're gonna show the model images of people who actually have this COVID, right? So if we look down here, we can see these are images of patients, scan images of patients who have viral pneumonia. It's right here. You can see how it is. So we're gonna be showing the model all this, and secondly, we're gonna show the model images. We're gonna show the model images of how the people who have COVID, this is the scan. Okay. So this resource is actually gotten from Kaggle. So in case you're wondering where you can get this, I'm just gonna drop the link below. So yeah, these are the images of people who have COVID, and here is a perfect image of people who their lungs is absolutely good and perfect. They don't have no problem at all. They don't have no pneumonia. They don't have no COVID. So these particular images is gonna be, we're gonna feed it to the model, and the model can perform the classification based off of what is coming in as a scan image. So if a patient walks in right now, they want to know if they have COVID. They have to run an X-ray to see how the lungs looks like. And during COVID, they have a lot of patients, and it could be somewhat impossible for doctors to be efficient, scanning and checking all those things. And model like this can come in and help that situation. So without taking much time, let's dive right into it. Right, so here we go. We are in VS Code editor, and here we have we're into the COVID scanner, directory. And so the very first thing we want to do right here is just create a simple, I can call this script. This is where our training code and all that will be in. Once you do that, I'm just gonna go ahead and give a list of things that we're gonna be needing for this project, libraries we're gonna be needing for this project. We're gonna need TensorFlow, and another thing we're gonna need here, we're gonna need Matplot, stuff like, if we want to like do like the graph to show some stuff, which we're gonna do maybe later. And another thing we're gonna need is NumPy, and another one we're gonna need to install is Pandas, and then we're gonna need essays, kits, learn basically. So these are all the libraries. We can install them, by creating requirements the tst file here, right? And just basically come down here and copy all of this. Well, I can do Ctrl+C basically, and just come here and copy them, put them here, but I have to take them and comment them right there. So that way, we can install them directly without no problem, right? You can do it this way, doing it from the requirement, or you can just go ahead and just install them directly from the terminal. It don't matter, whichever way as long as you're getting your job done. But right before you start installing, we want to create a visual environment, right? So I'm just going to check this up here. And what we're going to do is, as you see the command right here, Python 3, we're just going to go VNV. And then whatever name we want to name our visual environment. Now, the visual environment helps you to put stuff, all your code and you know, all the libraries and all that you're going to be downloading and everything you're going to be doing into a container without installing it directly locally into your system. You don't need it there. So we just need all of these libraries inside a specific container, which is this particular project. So we're just going to go ahead and just name it anything. We can name it, you know, COVID, or I'm just going to go ahead and just name it VNV. It don't matter, whatever you want it to be. It's okay. So click OK, and it's just going to create that visual environment right here. You can see it up there. And we just activate it by calling source, and we're just going to go VNV, which is inside the folder. And there we're going to find the bin, and then we're going to call in the activate scripts. And right there, we can see right here, we've activated the visual environment. Now we are safe to install everything that we need to install for this project. So I'm just going to go ahead and clear this so we can have a clean slate. But in this case, I'm just going to go ahead and use some, you know, just install things directly from the terminal. I love it that way. Sometimes it's just pretty much, you know, if I don't have a lot I need to install, this is just 5 things. And sometimes some versions can differ, okay? So I'm just going to go ahead and just do it directly from the terminal. So here I'm just going to go pip install TensorFlow. And I'll wait for that one to install. And after that, I'm just going to go ahead and install the Matplotlib and install the NumPy, install the PNS, like all of those, right? I'll come back when I'm done with everything. All right, so after importing all the libraries that we need, the next thing we want to do is to structure our project the right way. So I actually have the script. This is where we're going to be training a model. And the next thing we want to look at is the data set, right? I'm just going to go ahead here and create a folder. And I'm going to call this folder dataset, because this is where we're going to be putting all of the image for testing and as well as training data sets. So in this folder, what I'm going to do is I'm going to open this review this file. So inside the data set, what I'm going to do is I'm going to copy this COVID-19 data sets, right? And I'll come here and just the train and the test, drag the folder. Basically, if you're on Windows, just copy and paste it. It's no problem at all. So I'm just going to drag the folder and drop it right in here, right? It's gone, actually. What I want to do is I just want to copy and paste, basically. Let me copy that. I just want to retain the original just in case I want to do something with it later. So I pasted right there. So this is our directory. When we go back here and open our data set, now we have the train data sets, which you're going to see the COVID. You see the COVID, you see the normal, and then you see the viral pneumonia. Okay. And inside that, inside this particular test data set, when we come to our train data set, we're going to see the COVID, the same thing, the normal, and then the viral. So when we train with this, all right, with this data set, we are going to test our model to see if it performs better with this data set right here. So once we have that, I think that's basically all we need right now to get started, all right? So the very first thing we got to do, first of all, we go into our scripts and we want to start importing, you know, all the libraries we actually downloaded earlier. So I'm just going to go ahead and do all the imports, and then eventually I'll tell you what to do, and then we just go from there, okay? So the very first thing we want to import here is we want to import the brainer here, which is the TensorFlow, okay? And the TensorFlow, we're going to import that as TF. Let's call that TF. That's the regular way, normal thing we do. You know, the machine learning engineers, we just call it TF. You can give that anything you want, actually, as long as you can remember them to use them throughout the code. That's fine. So we're just gonna go from TensorFlow. So I'm just gonna import Keras, actually, and then from there, from TensorFlow Keras, The processor, sorry, pre-processing, the image, because we are dealing with image here, so we need image data generator. So that is what is we're gonna use to import our images. So I'm just gonna import image data generator, right? So when I have that there, the next thing I want to import is from TensorFlow again, the keras. This time around, we want to work with our models, and we are going to import sequence. We're going to import sequential, right? And after that, we are going to go from TensorFlow again, the keras, the layers. We're going to import. This is our convolution. I'm going to explain this to you later. It's just so much interesting to work with this, actually. This is the main brainer, apart from, of course, keras. This is the main brainer of what is going to help us, process our images and all of that, right? So I'm just going to go convolutional 2D, right? I'm going to go mass pooling 2D. I'll explain to you what these things are eventually as we use them. But for right now, let's worry about importing them. So I'm just gonna go dense, and finally I'm gonna go dropout. All right. So having all that, this last one is basically, well, it's optional. If you want to plot some, like the graph and all that to see how your model is performing and all that, you can do that here, right? So we can just plot as PLT. All right, so that's pretty much it's right there. I don't know why this as is not working. Let me see. Oh, I'm sorry. It's supposed to be imports, not from. All right, so yeah, we have all we need, all the imports we need to get this model rolling. First thing first, let's load our data set. That's the first thing we want to do right here, right? So we're just going to come up here. I'm just going to kind of like give it a very nice look so that we know where we are in our projects. I'm going to call that data loading, and I'm just going to keep that. Sorry, oops. All right, so the very first thing we want to do here, let me come down a little. I'm going to call this train generator. All right, just call this variable train generator. We want to generate, our data. So we want to use what we created up here. Remember, the image generator, and I'm gonna put that right there. And this is gonna take in 3 arguments. The very first argument is every image has pixel between 0 and 255. Every image, any image you see, have that pixel 0 to 255, and we can rescale that to telling that particular image rescale between 1 to 255 makes them actually smaller, right? If we rescale them 1 over 255, we are actually making them smaller, 0 to basically just around 0 to 1 range. So what does this actually do? It helps the neural network to learn better. So it just kind of like help them to make them smaller. The bigger stuff, make it smaller so I can understand what's going on. So that's going to be the first argument here. I'm going to set rescale, and I'm going to put that to be 1 255. All right, so it's just going to rescale that. And then the second argument is going to be rotation range. And what do we mean by rotation range? I'm going to set that to 10. So what does it mean, rotation range? It means that randomly just rotates the image a little bit, right? So let's say we have this image. While the neural network is being trained, it's going to be rotating this image gradually just to make sure it captures it. So let's say somebody, for instance, is scanning this into this neural network, and the paper is slightly bent. It's still going to understand what's going on. So that is the importance of setting that particular parameter right there. So I'm just going to close that. So I'm just set that to 10, just rotate it a little bit, 10 and all that. So I'm gonna go to the third argument. The third argument is gonna be zoom range. So basically I'm gonna code zoom range, and how many should we give this? Let's just give it 0.1 basically. So what does this do actually? You might be wondering. Well, random, this is telling the model to randomly zoom in and out slightly so that it can capture what is going on. So training the model is just basically letting the model see these images and just take and study every part in the tiniest form to see what's going on in the tiniest, in the largest, in the widest, in the rotational form, every form, to know exactly what is going on so that it can keep in the memory whenever it sees something that looks exactly like what it has seen before. So if you look at this right now, it can just zoom in, zoom out, zoom in, zoom out. That's basically what this particular zoom range is telling it to do, right? All right, so with that being said, we actually set that. Well, we need another one to our validational generator to validate our model. So we're gonna go validation, but this time around we're still gonna use image generator though, but this time we just have to just set rescale. It's okay, we don't need all that extra for our validation set. We don't need all that, so we're just gonna set that because, like I said, every image have a scaling between 0, 1, 2, 255. So with that being said, we're gonna move further to the next thing, which is like we want to load the actual image now because we've created our pattern and know how we want it to look like by setting all those parameters. The next thing is to load the image. So I'm just going to come here and call the train generator, and I'll set that to train generator dots. Train gen dots. There's a sub function here which is flow from directory. So what it means by that, what are we talking about here? It means that we want to get our data from a directory, right? So this comes with different arguments. I think about 4 arguments. The very first one is going to be, where is our training data set? So our training data set is it's coming from dataset train. Just in case you're wondering where I got this from, remember our data set, we put it up here. If you have a different name for this, please, you got to change this, right? But for me right now, I have data sets and I have a train, the validation set and the train set right here. So I've actually put in the train right here. So you can see that my directory right here is corresponding with the one over here. So don't forget that. And we're going to go down to the second one. What we're going to do is, the second one is going to be target size. And the target size, we are going to put it to be 150. And what does that mean? It means that it should resize all the image to the same size. So sometimes, you might go into this particular image and this image is big, go into another one, the other one is the size, you can see them, it's clear. You can see this one is bigger, this one is lesser, this one is larger in size and in height, and this one is a little bigger than the previous one. Let's see this one is smaller than the previous one. So what we're doing right here is, I'm going to close all that. Sorry. Don't save. I'm going to close. So what we're doing there is, once we get those images, we want to automatically resize them to 150 by 150, right? The height and the width. So that is what that is doing. So we're going to go down to the next parameter right here, which is the batch size. The batch size, I'm just going to set this to 32. And what is this batch size doing? So this is to load 32 image at a time for training. So it's just going to be picking 32 at a time and train, make sure that is good. Once it's done training that, it's going to go back again and pick another one, another batch, and train again. So if it comes to this training set, it's going to pick a whole bunch of 32 images, train them, come back again, pick another 32, train them and all that. So that's what this is doing right here. And we're going to go to the last parameter here, which is like the class mode. And this class mode is going to be categorical. I'm going to explain that in a minute. So what is this class mode doing? So this means we have multiple classes, more than 2, right? So that's why we have categorically. We have multiple classes, more than 2. So that is the reason why we have this category right here. All right. So with that being said, we set the training data. The training data generator is set. So can we move forward? Of course. Voila, this is the brain of the whole model. We want to actually build the brain, which is the model itself. So here, I'm just going to comment that just to give it a little nice look. I'm just going to call it the model. Okay, and just call that there and close it up. All right, so what is the first thing we want to do here? Creating a model. Of course, I want to give it a variable name model. And here, this is where we're going to use the sequential. And I'm going to open that. It's going to take some parameters. And the very first one is the convolutional 2D, right? So you might be wondering, don't worry, I'm going to explain this in a bit. So I'm just going to go ahead and just put in, don't worry, I'm going to explain that in a bit. Let me just go ahead and see what we're doing. Here is 3, and we're going to use activation function. Activation. We're going to use ReLU. And input shape. We're going to just put 50 by 50. And that's the first argument. And then we'll use a mass pooling 2D. And we'll set that to 2, 2. All right, let me explain what's going on here. So we have the convolutional 2D, which is the one up here. So convolutional stands for 2D convolutional layer, right? It looks at small 3 times, 3 pixel region in the image to detect the pattern, like the edges on the curve. So if I open one image right now, it comes here. When I zoom it in all the way, so it comes here, it takes 3 by 3 and look at the pattern of what is going on. It takes note of that. That's the 3 by 3 you're seeing here, right? The 3 by 3. And then when we move forward to the next argument, we have 32. You might be wondering what that is. So this is just the number filter, like how many patterns detector we are using. So you can set that to 62, but it's recommended to actually start from 32. We can set this is just basically telling the model the number of filter, like how many patterns detector we are using. So talking about this particular ReLU, this actually makes negative value 0. It helps the network learn faster. So this is an activation function that helps our neural network that we're creating right now learns faster, right? So how does it learn faster? It makes it learn faster by making negative value 0. So let's just take it up and stop there. I don't want to go too deep on that one, but let's just move forward because we're looking at the timing of the video. Now we go to the last one, which is the input shape. The input shape takes in 3 arguments, actually. And the 3 arguments, I forgot to put one right here. That's 3 arguments, yes. It takes in 3 arguments. It takes in the height, the width, and then the color channel. So if we look at the height here is 150, the width is 150, and then the 3 right here represents RGB, which is 3 colors, RGB, right? So that's what this is, the input shape is all about. So we're just basically processing our image and coming down to the next one, which is like the mass pooling 2D. What does that mean? It actually takes the most important pixel in each 2 by 2, the most important pixel. So after scanning, boom, 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 it takes like the most important pixel among the scan. These things are happening in real time. So we're not going to see them, but we're setting these values. All right. So it takes a pixel in 2x2 blocks and reduce the image size by half. So it takes the 2x2 blocks and then reduce the image size, the size of that particular image, by half of the original size. So that's what this particular thing here is doing. So this keeps detail while removing noise. It's like zooming in slightly, like zooming out slightly and all that. So that's what this particular part is doing right here. Mask pooling 2D. So it's like it divides the, let me go back here. So it takes an 2x2 and then take it out and you know, change the size by 2, the original size. Let's say the size is you know, is 12. It's just going to divide it by 2. It becomes 6. So it's going to be slightly zoomed even more, right? It's going to be slightly zoomed forward even more. So the point here is the neural, which is the brain, is actually trying to get details, the pattern of what is going on. So by the time they scan a new image that has not been seen and they recognize that pattern, they know exactly where to take it to, right? So that's what is going on here. So, all right, with that being said, we're going to create another convolutional network, you know, set the mask pooling, you know, that's what we're going to do right now. So let's just create another one. So instead of, you know, doing from scratch, I'm just going to copy this and I'll put it down here. I advise you, if you are starting to code newly, please type these things out. Okay, type them out. It's very important so that you learn them, you learn how it goes, you learn how it works. But for this time, we're not going to need any inputs. We don't need that. It's the very first one is carrying the size. It depresses it, it compresses, as in, I mean, it shapes it into height 150, width 150, and we know we're dealing with RGB right now, so you don't necessarily need it on the second one, right? So that's being said, the second one is this particular second convolutional network takes the most important pixel as well. That's just basically going, you know, doing more like, I would say it deepens the layer more. It just takes the layer even more. It's just like something training and getting more information, and you have another man saying, hey, yeah, I gotta cross check what you've done just to make sure everything is okay. So see this man here as a quality assurance. Oh, you guys have done what you want to do? All right, I'm gonna go again and check it to see what's going on, right? But this man here do not need that extra energy, which is like this. This is the man who does the main job, get information, but this man here is not going to spend as much energy as this man. That's why we're not having the heights and the bills no more. This man already understand that this man right here, which is the second convolutional network, already understand what the first man have, the size, and knows his color, so it doesn't need that anymore. It just need the activation function. It needed the size of that, and then all of this, right, to go with. All right, so we go then to flatten. After that, we're going to flatten our network. And I'm going to explain to you what that flatten means. The flatten actually unrolls that 3D features map in a single line of numbers, right? So for example, if you have like, let me use this here. If you have like 3 times 3 times 3 times 4. So what we're going to have as the output, that we're going to have the output to be 36 numbers, right? So flatten turns it into the output is going to be 36, right? 3 times 3 times 4, it's going to be 36. So what's the flatten going to look like here? It's going to make that and turn that into x1, x2, and so on and so forth to like x36. So it's going to flatten it into just a one line, right? Just a single line of numbers, right? So it's like taking a Rubik cube and laying all the squares and rows. That's what it means basically. So with that being said, I'm just gonna, maybe I should leave this if you need to reference it, because I'll be sharing the link of this particular file later, and you can just go back and actually get this. So the next thing we're gonna have here, after flattening that, we want to create a dense. Yeah, so what's going to be in our dense? I'm going to explain that in a little bit. But here we're going to still use activation. It's going to be ReLU. All right. So what is this dense that we are talking about here? Right? So this particular part adds a fully connected layer. So every neuron connects to every previous neurons, right? This particular one goes, I'm gonna put like this here. All right, so this particular one connects to this, and this one connects to this. This one flattens everything, and this one now is connecting to this. This is what is going on, right? So it learns combination of the detection features, like for example the texture, the pattern, the pneumonia, the what is going on there, if it is clumped up together, if it's like, a lot. This is absolutely what is the dense basically. This is another layer added to the previous one. So what the end goal right here is to make sure we train this model and it becomes good. It becomes good as almost human beings to know exactly which one is which when it comes to deciding or classifying a healthy person from a person who has COVID, so, or pneumonia, right? So that is that on that one. And we're going to drop out here, and I'm going to explain to you what dropout means. I'm going to put that there. We're going to drop out. Going to drop that out, and in that dropout we're going to pass one parameter here. What is this dropout? Some of you might be wondering what dropout. So what dropout does is randomly turns off 50% of the neuron during training. It turns off 50%, and that's 0.5 we put there is the 50%. If I put in like let's say 0.6 or 60%, but I just want to turn off 50%. So it turns off 50% of the neurons during training. These as well, the dropouts, prevents overfitting. So memorizing trained data too much is not good. You don't want us to train a data and then give it a data set to look at and we test it, and by the time we go ahead and somebody walks into our hospital and we pass in the X-ray images, and now it's just could not perform better because it only performs better on the testing data sets. It's not performing better in a real life scenario. That's not a good model at all. So this dropout will help us balance that out, right? By making sure that, hey, listen, you just use this part, leave this part alone. Just making sure everything is not perfect only on the testing data, but imperfect when it comes to the outside data, which is data that it has never seen before, right? So that is what that dropout is doing there. And then finally, we are going to put in one more layer here. And that layer is going to be dense. And here we're going to pass 3. And in there, we're going to use an activation. I'm going to explain this in a minute. Activation of what? It's going to change a little bit. Instead of ReLU, we're going to use softmax, and I'm going to explain why that is, right? So the final layer basically outputs 3 probabilities. So if we are looking at 4 things, we definitely put 4 here, but we need 3, right? So it actually outputs 3 probabilities since we have 3 classes. It's just like the pneumonia, a person that have COVID, just like we have it here. Let me come back here. A person that have COVID, the normal, and then the viral pneumonia, right? So that's why we have this, because this is going to be our output. And we have 3 classes. So now, for example, let's say we have like 0.9, 0.5, 0.5. The model is 90% sure it's COVID. So if this particular one, which is like the softmax, this softmax actually is an activation function that helps us to give us just a better idea based off of the class of what is going on, the result of what the model came up with. So for example, if I have this, I'm going to put this in comments. If I have the final result to be, for example, let's say 0.9, and I go by 0.03 for the second class, and I go for 0.04, right? Right here, we already know that the model is 90% sure it's actually COVID, because we have COVID, we have normal, we have viral pneumonia. So this is 0.9. This is 0.3 probability. This is 0.04 probability. Which one is the highest here? The 0.9. So this is a COVID patient, basically. There's no doubt. So that is why we're having this right here. So there's no need to think too much about it. That's what that means. And let's move forward into compiling this particular model now. So I'm just going to come down here to make things a little nicer. I'm just going to comment that. Compiling of model. And I'm going to close that there. All right, let's compile this model. So I'm just going to call in the model. And I'm just going to call in compile. And I'm going to pass, just to make sure things going well. Now, if you want to compile your model, you need to pass 3 arguments. Sometimes it could be more, but for right now, it's just going to stick to 3. The first one is going to be an optimizer. And we're going to use Atom optimizer, right? If you check my video previously on where I explained this optimizers and different optimizers and what it does, you're going to understand the reason why we're using that. So what does optimizer Atom does? It's basically just automatically adjusts the learning speed. So if it's learning slow, it's just gonna, hey, Mr. Man, you need to hurry up, go up a little bit. If it's learning too fast, just like, Mr. Man, hey, calm down, go slow your roll. Okay, so that's what the optimizer is doing there. And the next one is gonna be our loss. And now you might be wondering, what am I doing by calling categorically cross entropy? Yeah, this is absolutely one thing that a lot of people don't get. So what this is used for, it is used for multi-class classification. So because we have 3 classes, not just one class, so we got to use categorical cross entropy. It is cross entropy. It's very, very important to know that. We're not just talking about one class here, so we got to use that for the loss. So for the metrics, I think we are going to use accuracy. That's the best for us to use for this particular purpose, and it shows how often prediction are correct. So if this particular matrix right here will show us the accuracy of how the model is performing, if it's actually correct, wrong, or not. This is absolutely what is doing the job here. All right. So with that being said, it is time for us to actually train our model, right? So I'm going to write another comment here, which is like training the model. All right. So we have that right there. All right. So how do we train this? Basically, because I want to put this on the I want to put this on the graph later so we can see how it works. I'm just going to save it into just a variable called history. You can call it hist if you want, but I'm just going to write it full. And here we can call our model.fit. This is the actual function that trains the model, right? And inside here we're going to pass 3 different parameters. The first one is going to be our train data. The second one is going to be the validation data, and the last one is going to be the epochs. How many times do you want our stuff to run, the model to run over and over again, just to make sure nothing is missing, right? So the first one is the training the training data. Train data. It's supposed to be a train, not train generator. That was an error from my part. All right, so I'm just gonna go back and just change this to train data. And so the train data, what the next one is gonna be our validation data. Did we even put our validation data? I think we just have a validation set, because you can see right here we only have a train and a test set, but we can create the validation sets from the train set. So what we got to do here is we just give a comment right here, training sets, and I'm just going to copy that. I want to create the validation set right now, so I'm just going to come down here, call it validation sets, and here there's one important thing we got to put here to let the computer know, or let the model know that, hey, you got to split the the whatever that's going on in the images in the train set. You got to split them up and just give us something to validate whatever that's going on. So for us to do that, we're going to call subsets here. Don't forget this is very important, and we call it training. Okay, so if you forget to put this part, it's just going to be a duplication of this, and you don't so what we're going to do is to call subsets, and we set this equals to we're going to call it validation, and we also set subsets on the training, and we call that equals to training. Don't forget to label it this, otherwise it's just going to be a problem. And we're going to say validation data, right? So that's how it works. Just as simple as that. We good, right? So make sure you give it the subset training and subset validation, and the model will take care of the rest. All right, so with that being said, we're going to come down here and we're going to call the validation data. Remember, we're still trying to compile our model, right? So we're going to calling the validation data equal to validation data. Okay, so once we have that, the last thing we want to add here is going to be the epoch. So the epoch is going to be 10. We just want to run through over and over again 10 times, right? So the feat is just telling the model that, hey, you're ready to be trained. The epoch actually means, which is the one I put in 10 here, it means the model sees the whole training data 10 times. The model will go through the data 10 times, the training data 10 times, and it will show us training accuracy and validation accuracy after the epochs. So let's move further right now. So we just want to do a little plotting. Remember when I told you we have histogram, and we're going to do some plotting right here just to see what's going on. It's not really, it's good to plot to see what's going on, but in this case I'm just going to do that so that we can see exactly what's going on. Sometimes when I write or when I train my model, I just skip this part sometimes, but it's really necessary sometimes to really just do it so that you can see exactly what is happening and how your model is being trained. So we're going to go ahead right now and visualize our training. Visualization, and we call that visualization. And here we're going to call in the plots, which is the PLT we created earlier. And we're going to call the plots, and we're going to plot in the history, which is our model that we just trained, and we're going to call the accuracy. And the second thing we're going to do there is we want to label the accuracy. We want to label that. We're going to call it train accuracy. And we gotta plot another one, so let's plot one more. Well, this one is going to hold the value accuracy though. So we're going to go again, the plots. And we're going to call history, which is the model we just trained, history. And we're going to call the value accuracy. And with that being said, we're going to label that. What should we label this? We're going to label this, let's call it validation accuracy. All right, so once we have that right there, the next thing we want to do here is we want to like plot legend. So I'm just going to call that plot legend. And the final thing we want to do, to show the graph, right? So I'm just going to call it a show right there, and we're good on that one. The graph is going to help us to see if the model is improving or overfitting, right? Just to help to see if overfitting is happening or if there's some improvement in, training the model. So that's what basically this graph is going to show us. So with that being said, we want to test our model right now. So voila, we're done. We just want to test it to see what's going on. I know some of you be wondering, just this few lines of code. Yep, deep learning is not as difficult as you may think, but it might be complex sometimes when you need to do some deeper stuff. All right, so let's test it out. So what we're going to do right now is I'm just going to call tests loss variable, and I want to go get the test loss, and I want to get the test accuracy as well. So I'm gonna get it from the model, which is the model we created earlier, and I'm gonna call evaluate it. I'm just gonna go to the taste data. Do we have taste data? No, we gotta go up and create it just like we created all this. So I'm just gonna come here. I'm gonna call the taste data sets. So I'm gonna call this tastes data, and I'm call that tests. All right, so make sure you're changing all this, and we don't need this for the taste. All right, so with that being said, we have the taste data right there, and we're gonna come down here and just do maybe a little printing. And what are we going to show right here on the printing? We can say tests accuracy, just to see what's happening, right? And we can just say tests accuracy, just to see what's happening, right? So now what we want to do is we can save the model after this. We can just come down here. Okay, oops, my bad. We can come down here and just do something like model that save, and I'm gonna call this COVID classifier model that's carrots is usually H5. So we can also do the carrots right there, but for now I'm just gonna leave it H5. That's okay. So having that, right now we can just go ahead and test our model to see what's going on. I'm gonna go ahead and save this. Go to File and Save, or you just go Control X, whichever one. Make sure you're saving it correctly, and just to see how our model is performing, let's test this particular project. So I'm just gonna go ahead and clear, and bring this up a little bit. I'm gonna call Python. Do we have some error somewhere? Yes. Where is this coming from? Okay, right here. So an error here. Do we have error anywhere else? I think everything's good now. Okay, so just gonna go ahead and save that again, and I'll go Python 3, and I will run my scripts.py. So we see Python 3 is not found. I'm gonna go Python scripts .py. All right, let's see what happens. Well, while that is going on, we can create a little script to, predict a single image. So why that is actually loading up, because it can take some time to run. Of course, when you start building epochs and all that, we'll definitely see it. But let's just create a simple one. I'm sorry, no, I'm not creating that right there. I want to create it in here, so I'm just gonna go. I can name the file. Let me just name it predict1.py. So we want to predict one image. How do we go about it? We're just gonna go and right here we're gonna import TensorFlow. So I'm just gonna go from TensorFlow .keras preprocessing. I want to import here. What do I want to import? I want to import image, right? So after that, what I want to do here is I want to actually get one image. So I'm just going to give it a little space up there. So I'm going to save it into something called img, which is still kind of like image, but I just wanted to note it that way. Oh, okay. So the problem here is sequential. The spelling is actually wrong. My bad. So I'm just going to go ahead and change that. A sequential, it probably affects all the places. So see, I'm just going to go ahead and change them. And if you make that mistake, just like me, make sure you go back and change them. All right, I think everything looks good now. So, yep. Yeah, everything looks good. Let me see. We got. Okay, it's coming up. All right, pretty much it. It's training now, but we have another error right here. So let's see what we have. Line 76. So what could be the problem here? So when we look into this problem, we can see that the problem is coming from validation split. So I think there's a problem up here from the data set from the very beginning. So I'm going to go up here and see what's going on. All right, so we did not add one more thing. We need to add one more thing here since we are using the same training data. We're using the same training data as validation data. We need to let the image data generator to know that we are going to be splitting the data in the future by assigning 0.2, which is the portion we want to give to the validation split or the validation data set. So having done that, let's try again and see what happens to our code. All right, I'm just going to raise this a little bit up here, and I'm going to clear this. Start it clean and go back and let's run the code and see. All right, I think it's working perfectly well. We can see our loss. We can see our accuracy is 0.4, and it's going back over and over. You can see the epoch is going 1, 2, 3, 4. It's going to go all the way up to 8, and finally, our model will be working fine. So here we go in 7 and 9. How many epochs did I put in? Hold on. Oh, 10 actually. So this is the last one. Boom, right here. So here we go. We have we can see that a training accuracy over our validation accuracy. It's not overfitting basically, but let's go ahead and just see. They are not all up close together. Looks like a pretty good model, but yeah. We can do all the hyperparameters later, but I think this is absolutely fine. Let's go ahead and test and see absolutely how it's going to interpret that particular image that we're going to be testing it with. I'm talking about the single one. So here, I'm just going to go ahead and close this. So once we close that, we'll see the total accuracy is 0.7, right? So you can see that your save model and HP file will save. Oh yeah, we can save it in .keras. It don't matter. So we can just come down here and just save this .keras. That should be fine. So yeah, let's let's just write a code to actually create predict just one image. And right here, like I have said earlier, we have a test image down here, and we picked this from a COVID patients. So I'm just gonna go ahead and test it. I'll write the code for testing it, because we have our model right here. You can see we have it in the H5 and we have it in the keras. H5 is probably the previous way of saving your model using keras, but keras is wanting everybody to use keras .keras extension right now instead of the H5. It doesn't mean that the H5 don't work, but they're trying to get that off eventually. So that's why you're seeing this two model right here. We've trained our model and we have them in here. Let's go ahead and write a code to test individual image to see if our model is working well or not. So here I have an image. I picked it up from the COVID patient inside the training, the testing model, the testing data set, just to see if our model can tell if this is, a COVID patient or not. And then maybe I can go to the internet and see if I can find just a random one and see if that is going to dictate, if it's going to work as well for data that's never been seen at all. So yeah, so I'm just going to go ahead right now and start writing the code. So inside the predict, first of all, we want to import, image, a way of loading an image from the local file. So here we're going to use TensorFlow as well. So I'm going to go from TensorFlow.keras.preprocessing, and I'm going to import image. We'll call that image. So the second thing that I need to import is I need to import load model, and this is actually coming from TensorFlow as well. That we're going to use this to load the model, which is this one, the keras that we have trained already. So I'm just going to go here and say from TensorFlow.keras.models, and I'm going to import load model. Alright, so haven't done that. The last thing we need to import here is the NumPy. NumPy is going to help us. By the time the prediction comes out, it's going to come out into the arrays, and we're going to use NumPy to definitely just get the highest number, the highest probability, and translate that into a readable, human readable, prediction. So I'm just going to go ahead right now and just call in imports NumPy as np. So the very first thing is to load your trained model. So I'm just going to come here, load trained model. So here I'm going to call in the model, and I'm going to go load model, and I'll pass in our model, which is this particular one, COVID classifier. COVID classifier model. COVID classifier model.keras. All right, so once we have that there, we load our model. The second thing we want to do is to define a class label, right? So we want to make sure that we define class label. So how does that look like? We're going to call it class label. So we have COVID, we have COVID, we have normal, we have people who have pneumonia. So want to make sure we have that put in like a dictionary to help us remember what we're doing. By the time you're gonna see where we're gonna use this. So we're gonna set the first one, which is COVID. We're gonna put that in 0. We'll call that COVID-19 basically. And what about the second one, which is like 1? We're gonna give that a normal. This is a normal person, right? They don't have no COVID. You can see it right here. And then finally, number 2, we're gonna call those people the pneumonia patients. So we're gonna call them pneumonia patients. So yeah, these are our classes. These are the 3 classes we have. Remember when we was training the model, we absolutely put in a layer to export 3 class here, right here, 3. We use softmax to give us the probability, and I'll give you an example right here. This is how we're gonna have it. It's just that it's gonna be in 2D array, right? By the time it comes out, but we are going to actually we're definitely going to work on that using NumPy to give us automatically the highest, the highest figure, and we can use that to just display whatever thing we want to display. But yeah, let's take it next step. What we doing next? So the next thing we're going to do right here is to load and pre-process the image, right? We want to load this image and pre-process it. So what do we do first? We're just going to give a variable called img, and we're going to call the image, the one we imported up here. And what I'm going to do is I'm going to call load image, and right there I'm going to pass the name of the image here, test.jpg. Oh, jpg, sorry. And we're going to set the target size. The target size is going to be 150 by 150. That's what we used to train the data, so we just don't want to go something outside of that. All right, so having said that, the next thing we've got to do here, I'm sorry, I think we have, yeah. The next thing we have to do here is to make sure we convert this image into arrays. Your computer or the model, they understand just this image straight up. It doesn't understand this. You need to divide it into, you need to convert it into arrays, all right? So that the the model can understand better what you're talking about. So here I'm just going to call this image array just to give it that. I'm going to set that. We use image right here. We have another image to array right inside that function to array. And I'm going to pass in the image I have up here from my file, right? So with that being said, apart from passing the image, I'm just going to divide that by the dimension, which is 2550, which I told you already all image have, all right, the pixels and all that. So we move forward. What's the next thing? We're going to take our image still, the image array, and we're going to set that equal to np. So when NumPy come, we're going to expand the dimensions, right? And NumPy expand dimensions. And here's what we're going to pass in. We're going to pass in our image array. And once we pass that, we want to set the axis to 0, right? So once we get that done, we're almost done. So here now it's time for us to make prediction. It's time for our model to make prediction because we got our model loaded up. I'm sorry, we got our model loaded up. We got our classes. We put them in a dictionary just to make sure we get them correctly. And here we've actually loaded the image, preprocessed the image. I'm gonna call that preprocess image. And it's time for us to make prediction out of this. Now we have our model, we have our image, and now it's time for us to make prediction. So here we're going to go, I'm going to call a variable named prediction, and I'm going to set that equal to, I'm going to call the model we created up here, and I'm going to say that predicts. Yes, we can predict directly that particular image array that we have created. So you can see that we're not passing the image directly, but we are passing the preprocessed image, the image array, so that this particular model can understand where and what is going on here. So yeah, I'm going to call in the predicted index. So what this is going to do is it's going to take the NumPy and just argue max the prediction, right? So it's gonna get it out of that its natural state and just kind of like give us the maximum index. So let me go back to the script. So right here, the example I gave you can see we have 0.9, 0.3, 0.4. Now which is the highest here? It is this, right? So it's giving us the index of this particular value here. So that is what argmax is doing, giving us the particular highest index. So what are we going to do with that particular value? We're going to come here and say predicted label. Predicted label and we set that equals to class label, right? Which is the what we created right here now, class label, and we're just gonna call that predicted index. We want to pass that predicted index right here that this argmax has given us. We want to pass it here. So if it is in position number 1, 0, 1, of course it's 0, of course. So if it is position number 0 in 0, if it's position number 0 in 1, if it's position number 0 in 2, that argmax is gonna 0, 0, 0, 1, 0, 2. The argmax is going to return that, and once it returns that, we use this class 1 right here, class label, to denote which particular one it is talking about. So if it's 0, it's going to return, it's going to give us here COVID-19. If it is 1, it's going to give us right here, this is going to return normal. If it is 2, it's going to return pneumonia, right? So that's how it works. And so finally, it's time for us to return friendly message. We can just return message to the user. So if we want to do this, we can say if predicted label, which is the one we're returning here, it's equals to COVID, which is 0 if it is equals to this, right? So what we want to do here is we want to pass a very good slick message to the user. So we want to print how do we print this? We'll just say this is a COVID patient, right? Does that make sense? Just a simple response, right? We can just use elif right here and say if the predicted label is equal to, what's the second one we have? What's second on our list? Normal, right? That's right here on our dictionary, normal. If it's equal to normal, what we want to do is print and say we want to say this is a normal patient. All right, so once we have that, we're going to have, let's say, finally we can say S. If none of that, then we want to say, we want to print and say this is a pneumonia patient. All right, cool. So this is more like a friendly message, right? So what if we just want to see the probability in real time? Just let us see it, just to know that, hey, if you know, just to know that whenever we see this, we want to see all of the possibilities to know that this is not returning the wrong message. So I'm just going to come down here and say print. First of all, I want to give like a little spaceman right there, and probably I can just say, just write it straight up, or better still do it. I can say like class probabilities, and now I want to use for loop to show for I label in class label the items, right? So what I want to do here is basically I'm trying to show all of the probability, and so that we can see all of them and know, you know, which one is which and why it is what it is, why this is showing us the correct you know, statements. So here I'm gonna print, and I'm gonna say just to format this, rather just use this one, and I'm just gonna pass in the label, pass the label. Yep, and once I pass that, I am going to now call prediction. And prediction, and I'm gonna go like the 0, of course, and I'm gonna say, 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 and I'm g We want to go 0 because this is absolutely returning double, so automatically all of this falls under 0. Now inside there we want to pass in x, right? Not x, I'm sorry, this is absolutely I right here. So we're going to pass in that index, and we want to times that by 100 so that we can get an accurate number. Okay, so once we have that, we're going to set that to two decimal float number. We don't need all that long number, so we're just going to set that way. And yeah, that's gonna be percent. I think that's gonna be about it. So let's just save this file and run this and see what we have. Okay. All right. So I'm just gonna come back here and I'm gonna run a Python predict one and see what we have. Did I even save the file? I don't think so. Okay. All right. Cool. This is a COVID patient. We can see it right here. It's a COVID patient. COVID-19 is 96.43%. The normal patient is 2%, and this pneumonia is 0.9%. So yeah, that's it. So let me pick one particular test, number 2, image from a person who have pneumonia, and test it out and see what we have, right? So let me come back here and go to like tests, and let me go for a viral pneumonia and just pick a random image, right? Let me copy that, and I'm gonna come here and paste that, and I'm going to rename it tests with the double T at the end. So we have 2 images here now. I'm gonna go ahead and change this image with a double T. So let's see what we have here. Let's see if it's going to predict it correctly to be a pneumonia patient, or it's going to be an error. So there's a problem right here. No search by directly. TSTT. Okay, this is actually JPEG. It's supposed to be JPG. So I'm just going to rename that format here to be JPG. Click enter, and then I'll go back here and just change stuff a little bit. Okay, yeah, just leave it the way it is, and I'm gonna run the file again, and just to see if we're gonna get a pneumonia patient. If it goes pneumonia patient, that's absolutely cool. All right, so this is a pneumonia patient. Awesome. So we have absolutely successfully created a model that can just tell us right in there if a person have a COVID or have a pneumonia. Let's try one more to wrap it up. Let's try from the normal patients. I'm just gonna copy this one and just paste it right in here. Paste item, and then I'm gonna come here. I think I need to rename the item. Let me rename it right here. I'm gonna give it test. We did 3T, right? Oh, let me rename it JPG from here. So I'm just gonna rename it JPG and just go here and add one more test right here just to make sure. And let's see if it's gonna see that particular lungs as a normal lungs. All right, so this is a normal patient. All right, cool. So our model is working perfectly well. Just go to Google and just search for a scan image of a COVID. A long scan. I don't know how to put this, but just a long scan image of a COVID patient. So let me see if it's gonna bring out anything. I'm just gonna go to image, and yeah. We have one right here. So our data has never seen this before, right? So we just randomly downloading this. Let me save it to, I'm gonna save this right now. All right, so I'm gonna save this right now to download. I'm gonna save it as TEX, right? And I'll save that under download. And I'm just gonna go and import that from downloads. Let's go randomly from downloads to see what we have. So I'm going to go to download. This is it. I just downloaded it. Remember, our data, this particular image is not in our data sets. Never seen it. Our model has never seen this data before. So we're just going to take that and put it right here. Let's go back here. We have TEX. I'm just going to go right here and take this out, TEX, and save that. So let's see what it's going to predict for this particular unseen, never seen this image before. So let's see, we picked it up as a COVID patient image. So let's see, as a COVID patient perfectly. See, this is a random image from the internet, and it's saying that this is a COVID patient with a probability of 99.9. That's almost 100. This is powerful. This is amazing. Well, thank you very much, guys, for joining me through this journey from the beginning to the end. We have a model right now that can absolutely tell if a person is having pneumonia or having COVID, or even a normal patient. So with all that being said, I hope you've learned a lot from this lesson. Don't forget to subscribe, forget to like and share to people that really want to get into deep learning, machine learning as well. So thank you very much, guys, for following me all through this. I appreciate you, and bye for now.